Hi everyone, welcome to our presentation, Working with Custom Coordinate Systems in ContextCapture. Many of you out there may have worked with coordinate systems within your ContextCapture project. Perhaps you use spatial data in the form of ground control or outputting a production in a coordinate system based off geographic information that was tagged on your imagery. You may have even worked with LiDAR data and had to import the coordinate system as you imported that data. Today, we're going to show you how to generate a custom coordinate system. So this is a coordinate system that is not delivered within ContextCapture. We're going to look at the limitations and capabilities within ContextCapture when creating a custom coordinate system. We also want to be sure that you know how to access the libraries that are in ContextCapture to obtain existing definitions, and also how to search outside of ContextCapture for new definitions that may have been predefined. We'll then look at how to format a custom coordinate system as a WKT or PRJ file. And finally, we'll look at how to do a quick verification on the grid that you develop. We'll begin by looking at some of the capabilities and limitations when creating these coordinate systems. ContextCapture contains a spatial reference system database containing most country and state grids in both metric and imperial units where required. These libraries are broken down into categories that include Cartesian systems, geographic systems, projected systems, and user-defined systems. Along with the geographic coordinate systems, we also include several vertical datums. By default, ContextCapture will use EGM96 vertical datum. The vertical datum can be changed by overriding the vertical datum when selecting the coordinate system. Currently installed within ContextCapture are the AUS98 geoid model, EMG96 geoid model, NAVD88 in both meters and US survey feet, and NGF IGN96. Looking at the need for custom coordinate systems, localized coordinate systems such as county grids and custom project or plant systems are supported through the use of WKT or PRJ files. Limitations to these customizations include scale and rotation factors, as these are affine transformations that are not supported, and ground coordinates, which does have some partial support. However, anything with a scale or that involves rotation will not be supported. Coordinate system library files are automatically installed into the GDAL folder of the ContextCapture installation. The path shown here in the slide. The Spatial Reference System database can be accessed during any number of operations in ContextCapture, including Survey tab, import of survey data, Photo tab, display of the SRS of geotagged images, Point Cloud tab on import of laser scan data, and finally the production where you can specify the output coordinate system. Here you see the access to the vertical datum from the Spatial Reference System database. It's critical that the user understand which coordinate system and vertical datum were referenced in the acquisition to align the reality model to other spatial data. Overriding vertical coordinate systems can be applied when selecting the coordinate system. Next, we'll look at custom formatting. Adding a custom coordinate system involves using the spatial reference system database. Toward the bottom of the database, you can find the user-defined system section. Under this section, the user merely needs to define a new user-defined system. So let's have a look. Here we've set up a basic project. Here we'll access our spatial database by selecting an image and going over to our spatial reference system. Even though we're not going to change the spatial reference system on the image, we'll simply open our spatial reference dialog. Toward the bottom of our dialog, we'll see user-defined systems. Keep in mind, anytime we've overrode or used a vertical datum override, it will be listed in a user-defined system, because here we've combined the geographic coordinate system with a new vertical datum. To add a new system, we'll select the Define New User-Defined System. From this section, on this selection, we can begin editing our defined system. We can give it a name and we can begin editing text, or we can load a file. Let's go back and look at our slides and we'll pick up on this in just a minute. So the next step in formatting a custom coordinate system is knowing what the definition of that system is. So there are many localized coordinate systems with predefined definition, such as localized county or specialized transportation grids. These can usually be found online from a site such as spatialreference.org. We can take the definition that we obtain from a site like spatialreference.org and we can place it into a well-known text or WKT or a PRJ file. These files can be directly downloaded from spatialreference.org if they're available. If not, other localized definitions may be published with a local agency. You need to use a known, or you can use a known definition as a starting point for editing or formatting of a WKT or PRJ. We're going to go through a brief example using a custom coordinate system that we need to enter for a county within the state of Minnesota. So to access this, we're going to go to spatialreference.org. So let's go back. So back in our project, with our reference dialog open, we'll use the URL. Once open, we can search for Rice or Rice County. Results are returned. In this case, we know the definition is 6795. Perhaps we found this on the county's website or by talking to the county engineer or surveyor. When we click on the definition, there are several formats that we can download or view this in. We're going to be interested in the human readable OGC WKT file. Other formats may also work, such as a PRJ file, but for us, or rather maybe even PRJ4, we're going to use the WKT. When we click on it, it pops up in our browser. Some of the formats may download. In this case, it will open in our browser and we can copy the text and place it in Notepad. So this is our coordinate system. So with our definition started, we'll look at what else we need to format. The custom spatial reference system definition can be directly entered into the definition window in ContextCapture, or we can generate a WKT or PRJ file. We've already started that by generating the text file. Creating the WKT file allows for the creation of more transferable libraries across an organization. Using the WKT format from spatialreference.org, we've copied the text into Notepad. One issue that we see with the text is the projection. ContextCapture requires a specific standard parallel definition to be applied. In this case, it's 2SP. So we're going to go back and edit our text file to include the 2SP definition. So in Notepad, we'll simply come in here to the projection underscore 2SP, and this will provide our new definition. The completed custom coordinate system at this stage could now be used. However, it will reference the default vertical datum. No override is available. So what we mean is when we come in, we could simply save that as a WKT and load the file, or we could now copy the definition and paste it and give it a name, and this could be used. However, if we use this, there will be no vertical datum override. So rather, what we're going to do is we're going to add the vertical datum. So the question becomes, how do we get the vertical datum definition? Some vertical datum definitions can be found at spatialreference.org. However, in our case, NAVD 88 in imperial or in survey feet is not available. If we were clever, we could probably edit the metric version. However, in ContextCapture, we already have the NAV 88 imperial or survey feet version. So how we'll get this is to combine any spatial reference system with a vertical datum. We'll export that new user-defined system, and then we'll open the resulting file in Notepad, and we'll copy the vertical datum out of that file. So this will be very apparent once we do it. So let's close our custom dialog, and while you see I already have one definition applied here, let's just go and we'll grab Minnesota. So we'll grab any spatial reference system from our dialog, and we'll come in and we'll override the vertical datum. And now, with this new coordinate system showing up in our user-defined system, we'll export it. Now we'll open Windows Explorer. We'll find the newly created system, and we'll simply open it in Notepad by clicking on it. So if we look, in this case, this is our state plane coordinate system. And about 2/3 of the way down, we see our vertical system. So there's a couple things to notice. One, our vertical system has a name, as does our project coordinate system or our normal state plane. So you see NAD 83 Minnesota North. But there's a new line that's added to the code. At the very top, it indicates that this is a compound coordinate system. So we'll show how to add that in just a second. Let's get the vertical coordinate system, and we'll simply copy that. We'll go back to our Rice County system. We'll just do a little bit of housekeeping. We'll tab over. So now we can see our vertical system under our county coordinate system. Now that we've added the vertical datum to our county coordinate system, we need to be sure that ContextCapture will read this. And we do this by inserting the custom spatial reference system header. By adding the vertical datum to our WKT, we have actually placed two definitions in one file without specifying the two definitions. Only the first definition will be read by ContextCapture. So in other words, if we don't go back now and add a header, it will not read the vertical datum. The header definition COMPD_CS needs to be added to read both definitions. Typically, the format for this header will be COMPD_CS, then the custom grid name plus the vertical datum name. Once we add this, we can then save the file with the file extension WKT. So let's go back. Okay, so now we're back in our file. So let's add the header information. So in this case, again, COMPD_CS, and then we have Rice County, Minnesota, which is right here in our project coordinate system, plus NAVD 88, which is right here. So the height, I believe, just simply indicates that this is a vertical. Okay, so now we'll come in here and we can save as, we'll change this to all files. And we'll just call this Rice County. And we'll save it. Now we're ready to use the coordinate system. Back in our ContextCapture in our spatial reference dialog, we can now click the Edit tab under the custom coordinate system. This time we'll load our file that we just created. We'll just say OK. Now our new coordinate system appears in our dialog. So we're going to cancel that, and we're actually going to import some survey points. So for our project, we'll come into Custom Text Format Wizard, and we're going to import survey points. So we have a survey control file generated within both state plane and also county coordinate system. So we're going to use the county grid. This is going to be a comma delimited file. And we're going to go into our spatial database. We can import our custom WKT file at this point, or in this case, we've already imported it, so we simply select it from our list. Now we go to our fields, and we'll set our point name. In this case, it's formatted Y, X, and Z, and we can import our controls. So as you can see, this is our finished county coordinate system example. The last thing we want to do is verify that our coordinate system is in fact accurate. Now, ultimately, the best way to verify this would be to generate a model and bring it into CAD software that also has the same coordinate system, and import the same ground control that we just added into that CAD software and make sure everything lines up on top of our reality model. But because we don't have that when we're just working through a project, we're going to export our control that we just brought into ContextCapture using the new county definition, and we're going to export that to some other application that uses geography or geographic coordinate systems such as Google Earth. And because Google Earth is spatially aware, we'll be able to get a real good idea whether or not our county coordinate system is accurate. Again, we added the survey controls to our project. We're going to choose, or we've chosen, the newly created Rice County grid. And next, we're going to export that control to a KML file. So back here in our survey tab, we'll simply do an export to KML, and we'll be exporting control points. And we'll just say OK. And our Google Earth, if it's installed on our machine, will open. Now, interestingly, Google Earth is actually a three-dimensional globe. So in areas where there's a great deal of topography relief, it'll be more readily apparent. But even on a flatter terrain such as this, we can see that our control points are in fact on the ground. So typically, if we're not using the correct vertical datum, or perhaps we switch the ellipsoid or geoid, we would either see the controls as under the ground, maybe not seeing them when we zoom in far because they would be under the ground, or they would float up in the air by about 100 feet, give or take. So in this case, everything looks good, and we can begin adding our imagery to our ground control and moving forward with our project. So this concludes our presentation today. If you have any questions, visit us at www.bentley.com and look for reality modeling. I thank you for your attendance.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.